Hey guys, welcome to question MM449 of the Maths Methods Fortify study guide. Now, we've got let the random variable x be normally distributed with mean 7.8 and standard deviation 1.4. Let z be the standard normal random variable such that z has a mean of 0 and a variance of 1. Find k such that the probability that x is greater than 3.6 equals the probability that z is less than k. Cool, so the probability that x is greater than 3.6 is everything from this point onwards, right? Because 3.6 is here, that's our x value. So we're looking for everything on that point. Now, we're looking for the probability that z is less than k, okay? So we know that our z value is going to have to be somewhere up here, right? Because we're going to have to go less than k. Now, the probability that x is greater than 3.6 is the same as the probability that x is less than 12, okay? So this is x is less than 12. This is x is greater than 3.6, or 12.0, let's say. Because 3.6 is 3 standard deviations away from the mean, and so is 12. Okay, so everything above that -3 value of z is the same as everything below that 12.0 value there. So that means that the probability that x is greater than 3.6 equals the probability that x is less than 12.0, which is the same as, we basically need to find our corresponding z value there, which is 3. Okay, so our corresponding z value for 3.6 is -3, and our corresponding z value for 12 is 3. So therefore, k is equal to 3. If you don't understand that, just hit me up in the comments below, but that's our first mark for part A, and now let's move on to part B. Now part B is a little trickier. It's a 2-mark question. And says, consider the fact that the probability that z is greater than 1 equals 0.16. Find the probability that x is greater than 6.4, given that x is less than 9.2. Awesome. So let's just figure out what we have to work out here. So the probability that x is, given this, is x is greater than 6.4 intersect x is less than 9.2 over the probability that x is less than 9.2. Awesome. Now, what we're really saying with this intersect is we're looking for the probability that x lies between 6.4 and 9.2, and that's over x is less than 9.2. Awesome. Now, the probability that x is between 6.4 and 9.2 is this bit in between here. Now, I'm just going to get rid of this top bit because we're not going to need that. So we're looking for the probability in here, right? That's our first part, that's our top bit there. Now what we're told is that the probability that z is greater than 1 is 0.16, okay? So, actually this needs to be, oh yeah, we're good, cool. So that means that at z equals 1, which is this point here, which actually corresponds to our x equals 9.2, that's 0.16, okay? Now we're looking for the space in between here, the probability in between here, which means we can actually say that because from this point onwards is 0.16, and because our normal distribution is symmetrical, that point onwards there is also 0.16, right? So all of this is the same. So this is 0.16 and this is 0.16. So this is actually everything that's left over, right? So this total thing should equal 1. So this bit, this top bit, is actually equal to 1 minus 0.16 minus 0.16, okay? And that's our top part there. This is actually our first mark in between here. The probability that x is less than 9.2, well, we know that the probability that x is greater than 9.2 is 0.16, which means that the probability that's less than that is 1 take away 0.16. Awesome. Now all of this is equal to 0.68. 1 minus 0.14 is 0.84. So I would say that this is the same as 68 on 84, because I would just move the decimals over. And simplifying this, we get 17 over 21. This is our second and final mark for part B, guys, and that actually wraps up MM449. So guys, if you have any questions about any of that, please hit me up in the comments below. But otherwise, thank you for watching, and I'll see you in the next video.